Аплодируем, да?
This was a round of applause, I guess, right? Yeah, let's continue. Moscow Python Conf 2023 at Moscow, Gorky Park. Happiness, fresh air, allergies.
Значит, расчленёнки не будет, потому что Василий изо всех сил сокращал свой доклад. Но
Cut in parts because Vasily has been cutting his presentation as much as possible. We will see the gut
Ладно, так и быть, 40 минут.
Vasily,
Погнали.
the 40 minutes are yours. Yeah, great to see so many people. I brought the presentation from Nizhny Novgorod about the gut of Python. And not only Python. And since we have been talking about the compiler, we need to introduce a few notions. You believe that front-end is something visual, back-end is at the back-end. But compiler is not like that. They have front-end parser from the code into some kind of syntactic tree, and back-end is what's actually being executed on the actual CPU or GPU or special PU. There's also middle-end that is in charge of, I mean, there are intermediary things in middle-end, and they are also in middle-end, in the back-end. But in middle-end, they're not related to the actual processor, but they are important in the back-end. That's the difference. Then we'll be talking in some more detail, particularly about Python. On this slide, this is the compiling conveyor on CPython. It's pretty much it. You can take a look and you can go and have a cup of coffee. No. Front end of Python is actually the so-called tokenizer, also a parser into a syntactic tree. Intermediary notion in Python is bytecode, and backend is the virtual machine that executes that one. And the coolest thing compared to other compiler in Python is they can actually drag it out of Python if you want to. All of the modules and built-in functions, which actually do all of this. It's called conveyor compiler, and it's great. There are some abbreviations that you don't know here. CFG, control flow graph, almost like bytecode, but there are some jumps uncalculated there. And now we'll look into some more details. So, tokenizer, a very simple thing. Roughly, we have 3 tokens. It's better to have 5 tokens, as they say, but tokenizer does not know anything about what it is, how it works. That's kind of a sequence of symbols or chunks of text. That is being then transmitted to the grammar, and the tokenized module in Python is not very useful. You can import it from a file and put it apart into tokens, but frankly, I have not encountered like real-life tasks that could be solved with a tokenizer. Mostly, it's hands-on with AST parser. And we'll take a look how we can work with that in the pure Python. So, you give the source code to the parser, AST parser, and you can see that there's some kind of tree. You can check the attributes, look that this is binary operation with 2 operands, left one and right one, and there are some numbers to it. Nothing extremely complicated. But there are more exciting things there than you may think. You can use it as a script, look at the help, or you can unparse something, and the most exciting thing is how can you actually look at what you've been unparsing. There's the so-called visitor pattern from pattern design that can allow you to kind of procedurally go through the syntactic tree at every node. We can drop a parser, a processor.
И, значит, можно обходить не только в режиме read-only, но и модифицировать это.
You can also not only do the read-only, but also modify the tree by adding nodes manually.
Ну или можно просто по генератору ходить, как циклом for.
Or we can just go down the generator with a for loop and go through every node.
Из интересного еще есть более легкая версия функции eval.
There's also the lightweight version of eval. Raise your hand if you know what eval is. Quite a few, great. There is a more lightweight version of it. It's more safe. Mostly it's not very secure. If you want to write a secure code,
не просто получить exception, а прямо уронить Python.
You can get the literal eval, just, you know, fail Python interpreter into the score dump if you want to.
Поэтому, да, опасайтесь.
Beware. And in addition to unparse, there's also a cool thing
обратно в исходный код преобразовать.
That you can actually transfer it into the source code, unparse.
В принципе, вы можете сформировать не из исходного кода,
you can put it together not from the source code, but
по какому-то своему алгоритму,
based on your very own algorithm, you can create the tree and
и вот вы сгенерили
do the unparse, and here you have the Python code, the source code. Congrats.
Немножко вот про историю. Вот текущий AST парсер,
a few words about this history of AST parser. It was introduced with Python 3.9. Before that, they had a parser based on LL1 grammar. Probably you don't know what this is about, but the major reason why it was slow and not so great, because in addition to abstract syntactic tree, they also had an intermediary tree that was kind of pushing the memory pretty well, sometimes too well. So, accordingly, Guido came together once and made a parser based on PG grammar without intermediate tree. It's more memory efficient and just faster. And one of the reasons why they created lib223, another kind of nail in the coffin of 2.7 is that the converter 2.3 to 3 was dependent on the old parser, and in 3.10 it was completely removed. I heard that there are some forks to 3 library that can convert 2.7 code with a pack parser, but that's extravagant. If we look at the images, here's how it looks as a plot. So, at the output of the grammar, we have some function generated automatically, the C function, which create different types of AST nodes. For every node, there is a function generated. So this generator was the old parser and the new parser. It's still there, but the grammar has become more gradual in the end. There are less crutches there.
В старом парсере. В новом это прям в грамматику включено, в правила грамматики.
This is included right into the rules of the grammar.
Мы здесь не будем, так сказать, вот про формальные грамматики долго рассказывать.
We will not be looking too much at the formal grammar. We will just not have enough time.
И клевая штука в Python то, что
another cool thing in Python is that
the
parser has been generated. We can generate it not only on C but in pure Python as well. For example, if you don't know anything about grammar, but you want to add some keyword, new keyword, try it. You did a PEP, for example. And you can generate for your new keyword something and add it into the grammar and make pure Python parser, check whether it's correct and generate it in C and make a pull request. But there are some drawbacks to that, which are inherent to Python parser. It has cross dependencies to current virtual machine, so we cannot just slice parser off the VM that's executing the bytecode, which would have been cool to make the distribution of code more compact, for example. But I believe that in the future, sometime, someday, they will slice it somehow. Maybe I will even help at that. And another point about application. I personally applied anti-plagiarism script for Python code. You know that students often, when they send you an assignment, hey,
иногда вообще ничего не переименовывает, иногда
sometimes even not remain anything. Sometimes they remain stuff and even swap methods, you know.
Сравнилка скриптов на основе AST дерева, она, так сказать,
So based on AST tree, I can compare the scripts, and
видно, кто у кого писал сразу же.
comparing tool
Значит, есть
is not sensitive to that kind of thing, so we can easily see who copied from whom. So there's a simple compiler which is not doesn't even really work, but it has two files within that show how to use visitor pattern, for example, to go around the AST tree. It's a very useful thing to look into and see how it's working. And in addition to that, there are decompilers from the bytecode to AST tree and then to the source code. The fresh versions of Python are not yet supported, but if you believe that you are distributing bytecode as a PyC file and you think that you're a closed source, congrats. That's been a mistake. But of course, you should only apply it only to kind of get to know this thing. I didn't mean anything. And now, going to the bytecode. From AST tree, Python compiles this bytecode. This is linear representation now. And for Python, that's kind of intermediary thing. Intermediary representation. Then I will be using the word IR, intermediate representation, IR. And according to the compiler theory, there are three shapes of IR. And bytecode is one of those. That's when we have the sequence of bytes, but in reality it's much better to look at the lines, roughly the printout of intermediary representation of IR, which as a matter of fact is very readable, and it's not really far from the source code. It's not yet an assembler. Don't be afraid, we'll take a look at that. So this is the example of the bytecode. We have this assembler module, and we can use the very same compile function, which we put the source code in. We can make it from the file, from the line, and we see here that the code of the function itself is the last four numbers. The rest is kind of the declaration. If we want to look at the function itself, we can be easier. We can look at the disassembler and just shove their function as an object. You don't need to compile. When we declare the function, we would define the function. It's there as a bytecode in lines. There are two parameters in the memory, and we disassemble it. In the bytecode, there are certain optimizations that we observe. In Python 3.11, for example, there's this thing called specialization of the bytecode, meaning that certain operations in the bytecode are becoming specialized for a particular data type. For example, this assembler can highlight that, and if we tell him that adaptive is true, we can actually heat that function up with the integers, and we see that addition is geared up for integers if we had them. And there's kind of a counter. We gave ints 10 times, but the counter says 53. I don't know why. Maybe there's some bit values in there.
То есть, грубо говоря, у нас более абстрактная инструкция превращается в более...
So the abstract instruction goes into the specialized, more adapted to data.
Также мы можем сделать
And also, we can make a step back.
То есть мы оптимизировали, когда у нас целые числа.
I mean, we have optimized for integers, now we have lines.
С плавающей точкой числа.
Or floats.
Через какое-то время
in a while,
инструкция понимает, что
the instruction understands that something is off here. We need to make a step back and then make a step forward, but in a different direction. So that's an acceleration, definitely. 10 to 60% when we were doing that. And in Python 3.12, that's been expanded. There will be a couple of instructions and more things, specialized more. But let's look at this function and feed lines to it. We fed 10 lines into it, and we see that our counter was 53, now it's 43. I mean, as many lines as we've input, but we still have addition for integers, so we have not cooled it enough yet. So we see that there is optimization. Binary operation has become adaptive, so it's returned to not what we used to have, but something similar. And we need to continue pressing on. And in the end, it says, well, you guys, I give up. Okay, that will be kind of a Unicode lines addition. As you have noticed, a bonus for attention, load fast instruction has also been optimized. It's become sort of double. 2 load fast instructions have become 1. Why this thing displays a second one, I don't know. It looks like MAGA. Or maybe that's the way it was supposed to be. There should be 1 double instruction.
Now,
bytecode, we can look at it. And by the way, it's useful to see certain instructions to compare formatting of lines via format and via f-strings. And you will see that f-strings have 1 bytecode command. And for formatting, there are more bytecode commands. By the way, that's why f-strings are so fast. Use them. And to continue, we need to execute that bytecode somehow. And let's now talk about VMs for a while. I mean, we should. It's getting nasty. Stack machine, a stack virtual machine. There are not only stack virtual machine, it's in the C-val evaluation loop. In Python, other compilers don't have that. That's actually cycle according to the instructions. And we can even look at how the addition instruction works. I decided to show the C code. It's not so scary. You can see here it's something reasonable. So there's this de-optimization if we are going to return to the abstract version of the instruction. So there is a statistical counter that expands. There is addition, and twice we're doing the decrement counter, so we decrement the counter of links. So where do we increment it then? I mean, we're decrementing it. How do we incrementing it? As a matter of fact, incrementation, incref, is happening in a previous instruction called load fast, which is quite logical, isn't it? I just didn't show you this right away. And also we see that there's a certain stack here, stack row, which, as a matter of fact, is not a call stack. That's a different entity, but the stack on which virtual machine works, that's a different kind of stack. And you don't have to know how it works, actually, if you don't want to write another VM. But you can. In one of the Python core developers from London, there is one. And generally, we could hope that it will be faster than the stack. So far, though, I heard no, and it will not get into 3.12. Maybe not even 3.13. But there is a development like that. And eval frame default, we've seen this function already. There's internal API which replaces this function into a virtual machine. And I could wrap up here, but no. There's a good book. CPython internals. It's quite detailed, right? A more compact version is a developer guide, where we see a lot of detail on the Python interpreter in a more concise way.
И, наверное, даже с dev-гайда стоит начать, а потом уже...
I think we should even begin with the dev guide and then get deeper into the book.
Вот, ну, подождите, жесть только еще начинается.
But look, wait,
собственно, про JIT
it's getting even nastier. Project compiler.
Обзор. Собственно, про PyPy все знают. Он написан на
Python. PyPy, it's written on AirPython.
Отличается довольно существенно в нескольких моментах от CPython.
It's different from CPython in many ways.
Сборка мусора
in certain ways. Garbage collection is done not with reference counters, but with so-called trace-based garbage collection, as it's been done with, for example, Java language ecosystem. But that's a particularity. It's not something negative, right? But something that's not that great is compatibility with C extensions. Everything that has wheels, NumPy pandas, all of those things are not quite compatible with PyPy. Let's just put it that way. And if you have C extensions, if you want to support them in PyPy, you need to rewrite the code with the C-types module. Raise your hand if you know this module and why you'd be using it. That's the conversion of types from Python to C. And calling, with this module, I mean built-in module, you can call C functions from pure Python. I do not talk about that in detail, but the point is that in PyPy, in order to make it fast, you need to write C types for this module. CFFI. Foreign Function Interface. Foreign coming from a different language. That's the thing. And I saw a comparison for performance, PyPy and CPython, and for beta 3.11, it's not really different from the release. And on average, personally, I see that 40% of acceleration, that's already not by many. Maybe by 3.13 or 3.14, CPython, in my opinion, must be faster than PyPy, inevitably, and PyPy will die, sadly, or fortunately. There are other JIT compilers, right? Like we've been talking about VMs. You can make a different one, or you can use a different one. Okay, PyGeon. Executed on a .NET VM, but the project I don't think will be growing. Some useful optimizations will be gradually transferred to CPython. In addition, there are some more promising developments which has been developed by the engineers from Facebook and FaceGram. That's a fork of Python purely with implementation, but not of the VM, but JIT compiler. I mean, as a PyPy, it's also a JIT compiler. It doesn't use any .NET. It has its very own implementation, and it doesn't use LLVM. It has two intermediary representations, high-level IR and low-level IR. And high-level IR similar to bytecode, but there's some different reference counting there, and it's been open sourced, but they have not been declaring that it will be fully compatible to CPython. Probably won't. At least in the CPython community, the Facebook engineers have been quite present. We will go into detail on JIT compilers, which can minimize certain functions. Probably you heard about number. And if you do have a certain function, here's a random example. It calculates whatever. You drop a decorator in this one with a ton of parameters. And cache that into disk, so that you don't have to compile it every time. Because compiling time is quite a lot. So you should use this function only if you call this function many, many times. Not for any functions. Don't JIT every single function, please. Number is using actually LLVM, a well-known compile ecosystem, and a lightweight Python wrapper.
Поддерживает довольно много всего.
And it supports quite a few things,
В том числе какие-то параллельные вещи,
including some parallel things and GPU-based execution. But an issue here is that with C extensions, again, it may be quite unpredictable, especially if you're using, I mean, it can be used with NumPy, but with pandas, NumPy doesn't understand it, and therefore, you will not get any acceleration. Even there will be overheads and things will be even slower. So if you have a lot of NumPy, Number can help you. Or maybe you have pure Python. I will not be talking a lot about implementation. There's a good presentation at the last PyCon, described in much detail. In the presentation, there is a link, and you can find it easily. Now let's take a look inside of the gut. Well, a typical compiler, compilation steps, not for Numba only, but also for other programming languages, like there's Julia language. Anyone heard about Julia programming language? Whoa! It also has at least two or even more intermediary representations. And for this kind of a dynamic compilers, you must show types. And LLVM ecosystem has been geared up to static languages. So you need to make dynamic types into static types. So intermediary representations, environments. We'll take a look at that. And a few words about types. Type output can be something relatively complex. There are some algorithms, but, well, let's use them. However, there are cases when these algorithms just don't stop. We cannot even call them algorithms, because algorithm-wise, it's just not solvable in any case. Some of you have long faces, I see. It might seem surprising, but in the article, and many thanks to Nikita Sobolev for the link, there is an example when MyPy just never stops. You need to try hard for that. You have to engineer that. It's not an easy thing to achieve, but still. So, question. You cannot make a compiler, can you? Well, you can. I'll tell you more in a C++ language. Templates also have types. And also, the system there in C++ templates also is unsolvable algorithm-wise. And in certain cases, the file is compiled for a long while. And you can come up with a few examples when compiling will just never stop. Unless there's a timeout, of course. In a Julia language, they simplified the type construction, and Lua, which is also simple. The system is even more simple. That's why Lua JIT is just so fast and small, but not everybody knows how to use it, though. So, let's return to the Numba. Hello, Ivan Butygin, by the way, in Munich. So, Numba, a simple example. We wrote some function which is not even optimal, intentionally, how this thing can optimize it. Constants are not filled, etc. And we see the result of it. A simple example, right? It's quite self-evident, right? It's a joke. If you take a closer look, though, you'll see some binary operations, some kind of product, sums, but you need to really dig into this one. This code gives some intermediary, scary image of the situation. So, let's now simplify this example even more. A plus B, right? Here at the bottom, by the way, Yeah.
Внизу немножечко видно, что у нас вот сложение двух целых чисел, аргумент А, аргумент Б.
We have argument I, argument B, two integers that we summed, and it's returned somewhere. A bit more clear, right? But still, a ton of auxiliary information which can be omitted. If you look at this intermediary representations from time to time, you know where to look for, by the way. And this is close to assembler, by the way, as you may see. We promised you an assembler. Here it is, but not completely, right? Now, let's talk about the ecosystem. Now we're getting into the gut of it. Ecosystem to create intermediary representations. Multi-level IR. Some people interpret it as machine learning because machine learning tools are using some call it multi-level. Because there's kind of a low-level and high-level representation, a dialect. In a dialect, we observe certain functions and operations and types. For example, linear algebra dialect, lin-alg, it supports the product of matrix, or you can transpose matrices. So you can do some high-level operations there. There you can transpose the matrix, and then we can transpose it again, and you get the same matrix. And therefore, we can kind of zero down two operations into one. And after that, after this kind of dwindling down, we can lower this representation to a more low level. A thin dialect, for example, is representation for 4 cycles and other operations, not only 4 cycles, for which you can make optimizations that are using some kind of math. So that's optimal math optimizations. We will not delve too deep into that. We just know that we can reuse them as ready-made. And after that, we can make low-level representations and execute that on a backend. There are also GPU dialects for NVIDIA, for AMD, which are also high-level and low-level. And the most important feature-wise, it's multi-level. We can take different levels, different dialects, and put them together, meaning that they can be mixed down in one intermediary representation. I think this is one of the coolest features of MLVMIR, because this is heterogeneous computation, naturally. Types and attributes, by the way, can be dynamic. We remember that Python is a dynamic language, and we could have done a dialect for Python. And we had a year ago, maybe a year and a half ago. And in dialects, there are ways to optimize current representation or lower it down to the next level.
Мы можем там из питоновского кода получить промежуточные представления.
Or we can intermediate representation from Python code and then get C code out of that. Or we can send it to execution.
Значит, инструменты, которые пользуются
the tools used by this ecosystem, there are 2 pretty self-evident examples here. All of the compilers of neural networks are using this.
Матричные все диалекты.
And all these matrix-based dialects, tensor, linear algebra, is something that they use a lot. And optimizers for neural network models are also using compiler infrastructure, and you just don't see that. Make me unsee that. Yeah. Gradually, Namba is moving to this ecosystem, and there are repos where that is being done, and even a dialect that they have now. But it's still static type at the moment. Dynamic types are not there yet. Maybe they will have, but I don't know. We'll see. And as a matter of fact, even Clunk, a very well-known C++ compiler, is also moving to MLIR. They're making intermediate representations on that in order to make code more maintainable, so it will be easier to go into the guts of Clang. But that's not something that I will be talking about. I promise that there will be no blood, only gut. In addition, MLIR has Python bidding, so you can use MLIR from pure Python. Unfortunately, we don't have that in PyP, so you cannot install it via pip. But there is this American dude, Maxim Leventhal. If Julia is named in honor of the wife of one of the developers, Nelly is named in the honor of the mother. And this thing can almost take almost pure Python code, a bit, muddled. You need to do quite a few imports for that. That's the deal. So that you take the pure Python code and transfer that into the intermediary representation for the mix of existing dialects. There are wheels so that you don't have to reassemble LLVM, because it's quite a while. And now let's take a look at this simple example. We'll need a few more imports for that, though, from Nelly. And let's see what IR will be generated by Nelly. Okay? Here, there are, I mean, it's a bit more comprehensible, I hope. So we have a for loop. We have some operations in there. 2 multiplied by 7 has been optimized to 14. Some optimization has happened. But I doubt that the zero constant, that is the percent of 3, is suspiciously within a cycle, although it should not be there. And if we try this intermediary high-level representation and put it down, for that we would need to actually use the utilities that's been already put together from MLIR. And an LVM that it depends on, but not assembled yet. We can load this optimization command here, and we can tell it, dude, please lower our dialects, convert into the lowest level dialect, LLVM, and it responds, nope. Let's see what's wrong. Okay, the percentage within a cycle, the variable. I should tell you that variables are all unique in this shape. SSA, it's called static single assignment, meaning that the x variable is always there once. If we look at the x variable for the second time and assign it for a second time, it's becoming x2, x3, etc. So, as a matter of fact, it's a different kind of object already. And we see that this variable %4 is within a loop, but nobody took it outside. And if we'll look further and look into the documentation to the dialect, then here are a few lines. This thing will even go down. And we see something more low level. We need to write down here type conversion, typecasts, which are unrealizing. If we look at the types and transfer them correctly, easier said than done, then we can broadcast it to the lowest level and execute on the LLVM interpreter. LLVI, I is for interpreter. And if we take a look at the scheme, then this dialect, the lowest level dialect is going down to LLVMIR, and we execute it. I mean, it almost works, right? We're almost approaching the end. Yep.
Python ускоряется, сохраняя интроспекцию, то есть мы можем все еще просветить байткод.
So Python accelerates, preserves introspection. We can still see how the bytecode is being optimized. It's pretty cool. We can actually see what's happening there.
Middle-end тулы тоже развиваются.
Middle-end tools are also getting better. Yes. they have certain bugs, indeed. But gradually it's getting better. In a couple of years, you'll be able to use it. With pure Python. As a matter of fact, this kind of a compiler ecosystems, there's a number of them. I cannot help but mention them. There's Graal VM with the GPA licensing, though. There's also Arc compiler, which also dynamic type. It supports dynamic type languages, but both Graal and Arc compiler, they are supported by one company. LLVM accepts contribution from so many companies, people, universities, you name it. That's why I prefer this one. And the fact that you can use MLIR from pure Python, that's great, thanks to the fact that you can add dynamic types and operations. And from Python and for Python. And not only for Python. And also,
Малир для создания собственных языков программирования. Например,
we can use MLIR to create your very own coding languages.
Не хочется повторять все остальные фичи, которые уже есть в других языках.
And you don't want to replicate other features in the other languages.
Из MLIR существующие диалекты, и все как бы старые фичи уже с вами. Ну, там только
you take all of the things from MLIR, and all of the basic features are with you. Just need to add a few front-end things. Quite a few. And you concentrate on the new ones then. So, I believe that in a few years we'll have another boom of coding languages just because it will be so much easier to make your very own.
Ну, я надеюсь, кто-то что-то понял и, наверное, задаст осмысленный вопрос.
Maybe you will ask a few questions.
Смотрите, уже бегут курьеры.
The delivery guys are running with the mics.
Delivery Club сделали футболок.
There's a reason why we use this delivery club.
Получился. Поехали.
So, let's run it.
Спасибо за доклад.
Thank you for the presentation. Here's the question. Since in we mentioned TensorFlow. TensorFlow now allows to compile neural networks for microcontrollers right out of Python code. So there's some bytecode being put together there, and then that bytecode is going into executable code for microcontrollers. How is that happening? Is it within some kind of a Python machine? And there's another machine within that that actually puts together the code for microcontroller. Yeah, that's a good question. That's curious about microcontrollers. As a matter of fact, in LLVM, there are no microcontrollers backend for like these very compact devices. There's MicroPython for that. That's not related to what I was talking about. So if we speak about microcontrollers, I believe that probably no. There are other types of development. So how's that happening? I know for sure that from Python, I can start some method from TensorFlow, from some class, and put together a code that I can actually put into the microcontroller. That should be somewhere within the Python. Let's clarify that. Are you talking about microcontrollers, special computational units? Yes, at the TensorFlow website, there is one. Because microcontroller is a bit of a different thing. Yeah. A microcontroller with a DSP cores. Maybe for certain dialects, there's a special kind of backend. That's not within LLVM, but in the TensorFlow repo. And maybe it can take its own backend and move it to DSP processor. A small question about lazy computation. PySpark allows you to not to compute something right away, but make a certain method, and then in a while kind of get another method, etc., etc. How's with this lazy computations on Python? I cannot tell you about Spark. I don't know Spark that well. I don't know what's happening inside.
Так,
okay, thank you.
Микрофон вам сейчас бросит, как футбольный мяч.
Здравствуйте, спасибо за доклад, он был очень интересный. У меня на самом деле вопросы 3 либо 4.
A very interesting presentation. I have like 4 questions.
Первый вопрос, соответственно, когда вы заговорили
Question
про
one,
прогрев функций,
when you began
мне бы
talking
хотелось
about
узнать, влияют ли
heating functions up,
тайп-хинтинги на прогрев функций, потому
does
что, насколько
type
я слышал, в
hinting
рантайме
affect that?
тайп-хинтинги
Because I've heard
практически не
in
участвуют,
runtime
но, однако,
type hinting is
когда,
not even
например,
participating
dir
much.
какому-то
But when
какой-то
I
функции либо классу проводил,
get
то
dir
там
to
я эти
certain function or
тайп-хинтинги
class,
видел.
I saw
Вопрос,
those
влияют
type
ли они на,
hinting.
соответственно,
Does that make an
оптимизацию
impact
bytecode
on
явления?
bytecode
Нет, не влияет.
optimization? No,
Следующий
not
вопрос.
really, no.
Вообще,
Next
старик, когда у
question.
тебя 4 вопроса,
Dude,
ты
when you have
говоришь,
4
Василий,
questions,
а вы
Vasily,
согласитесь прогуляться со мной по парку Горького
can you
и
take a
поговорить?
walk in Gorky Park with me and have a
Тем более,
conversation?
это же,
No
блин,
problem, by
парк
the way.
Горького. Да,
It's
пожалуйста.
a Gorky Park, of
Да.
course.
Вот.
The hardcore
Соответственно,
question.
дальше, есть ли вообще будущее у PyPy и Numba?
Does
Возможно, вы
PyPy
слышали
and Numba
про
have the
Nuitку
future?
и такой
Maybe you
новый
heard about
язык
Nuitka
Mojo,
and the new language
который,
Mojo,
говорят, что он очень
which,
быстрый,
as they say,
при этом
is
похож на
very
Python.
fast and really Python-like.
Да, я отвечу, да, про Nuitку я слышал.
I heard about Nuit.
Про PyPy я уже сказал, что, скорее всего, он
About PyPy, I said that it's probably gonna die,
по моему мнению, да.
in my
По
opinion.
поводу Mojo,
As
да,
for
я смотрел,
Mojo,
это, конечно же, из
yeah.
всех кругов показывали, да.
Everybody's
Там
speaking
они
about
как-то
Mojo.
используют Muller, но они пока не выложили это в open
They're
source.
using Muller
Как именно
somehow,
они
but
это
it's not yet
делают,
open
пока
source.
непонятно.
How they're doing this, I don't
И
know.
есть вопросы к тому, как они это мерили.
Maybe there are
Возможно,
issues on their
измерения
measurements
заточены под конкретный
because
пример.
maybe they have
В
been
принципе,
adjusting
вот
their
в Python в том
measurements
же
for a
есть,
certain
вот
example.
CPython бенчмарки, которые могут мерить, ну,
There are CPython
бенчмарков много,
benchmarks which
и можно
can
померить
measure
перформанс
different
в
kind of
среднем.
things, and you can
И
get
когда
the
говорят,
average
что вот, например, Python
performance.
3.11
And
там
when
на
they say that Python
25% быстрее
3.11
Python
is
3.10,
25%
это значит,
faster
что он
than
в среднем
Python
быстрее
3.10,
по всем
it says that
бенчмаркам,
it's
которые
on
вот есть у
average
Python.
faster for all of the CPython
Чтобы ты не
benchmarks.
платил за третий вопрос.
So
Вот,
that you don't
пожалуйста.
have to pay for the third question. Yeah.
Да, привет. Ну, мой вопрос частично
Hi.
украли. Я хотел как раз...
My question was partially stolen. I wanted to ask about Mojo, but let me rephrase.
Душнило из
My name is Коля. I'm this dude from Litres.
Ты говорил то, что будут появляться
You were
языки,
saying that
которые там будут проще, быстрее
There will be
делать,
languages
да,
which
то
will
есть
be
будут
easier and
больше
faster and
появляться.
easier to
Как
make.
ты
There will
вообще
be
это
more of
видишь? То
those.
есть будут
How do you
появляться
see that? I
какие-то
mean,
множество по типу моджи, и все будут переходить на них. То есть будет что-то типа как TypeScript
will there
для
be like a lot of
JS,
different
Elixir для Erlang,
stuff
типа
like
будет
Elixir
тоже
for
какой-то путь
Erlang,
развития,
TypeScript
или
for
же это всё
JS,
забьют и
and
такие,
Python will go that way, or everybody will forget about that and it will just
Python, просто было
put
быстрее.
everything into standard Python implementation so that it's just faster. That's a
Что будет просто
metaphysical
только Kotlin, и
question.
больше ничего. Вот.
Да,
Maybe they will be just Kotlin and that's it.
так, два вопроса, по-моему, было. Вот по
Two
поводу
questions in one,
того,
actually.
Что все на кого-то перейдут. Тут
Somebody will move to something.
И кто как сделал
It's the issue of
простым
promotion,
использованием это.
I
Если
think,
нет,
and
Смотри, мне скорее интересно
simplification.
твое именно мнение.
Ease of
то есть,
use, but
по
your
какому
opinion.
из
I
двух
want to hear
путей
your
пойдет
opinion.
Python? По
Which
пути
will be the two
настройки,
ways
да,
of
то есть
Python?
добавление какого-то
Extensions,
множества
I
над
mean,
языком,
adding like
как
the
тоже TypeScript или
multiplications
Elixir,
of
да,
languages
над,
like
своими там
TypeScript
языками
or
глобальными.
Elixir
Или же не будет
over the
никаких
core
множеств,
languages,
и
or
будет именно
there will be no
такое более
extension
глубокое
and there will be
развитие
kind of
ошибок,
deeper
и
development.
чтобы Python
So
становился
not
как бы быстрее
extension,
в
but
целом. Может
kind
быть,
of
новый синтаксис мог там к
deepening.
нему добавляться,
Maybe
или
new
просто
syntax added to
оптимизация.
Python or just
Я
optimization.
думаю, что на самом деле развитие
I believe
будет идти
that
в нескольких
the
сразу во
development will
многих
be
направлениях,
going
и
into
просто
many
какие-то
directions at
отсохнут,
once,
за
and some branches
неточностью.
will
Ну,
just
сам
become
какой веришь
inefficient.
больше?
Which you believe more?
Я вообще верю на самом деле в MLIR и вот эти куски.
I believe into
переюзанные, да, но на
MLIR
самом деле
and
там
this
тоже могут
reused
быть нюансы.
chunks, but there
Понял,
are some
спасибо.
caveats as well. Thanks.
Возвращаемся.
Ага,
Да,
так.
сейчас, секундочку.
И самый последний вопрос.
Вот.
Почему,
The last
например,
question.
у JavaScript есть несколько движков.
JavaScript has a few
Условно говоря,
engines,
там V8,
like
который
V8
от Google и там
from Google
SpiderMonkey
and
от Mozilla.
SpiderMonkey from
Соответственно,
Mozilla.
Почему вот
Why
V8 он отличается более высокой
V8 is
производительностью,
different because
при
it's
этом,
faster?
допустим, почему для Python как бы и не могут...
Why for Python they cannot make that kind of thing, in your opinion?
Ну, мочь-то могут, другой
Maybe
дело
they
хотят,
can.
да, на самом деле,
Maybe they just don't want
Java
to.
сделали же как раз
For
регистрированную
Java,
виртуальную
they
машину,
did this
которую в
registry
Python вы пока не
VM,
делали, и
which
она
they have
вроде
not
как себя
yet
показала быстрее, насколько я
finished with
знаю. Хотя
Python.
я
It
вот не
seems
завис,
to be
поэтому
faster.
это
I'm not a Java guy,
говорю,
but
да.
I'm just saying.
А именно в Python, ну, если кто-то вот эту разработку
Python,
делает и оптимизирует хорошо,
If somebody can make that happen for processors, that's great.
то как бы возможно будет так же. Ну,
Maybe it will be an improvement.
И сразу,
Thanks,
кто готов?
bye-bye.
Кто это сделает? Вот подпишитесь. Да, по традиции вы передаете микрофон, да, это уже сложившаяся логистическая цепочка. Пожалуйста.
Спасибо, очень крутой доклад. У меня такой вопрос.
Thank you. Awesome
Ты сказал,
presentation.
что Python
Question. You
будет
said
ускоряться
that
дальше, и в
Python
итоге
will
станет
be
быстрее,
accelerating
чем
and will
PyPy.
become faster than PyPy.
За счет чего
Probably.
он это сделает?
How?
Появится просто JIT? Или
Will it have a JIT
что-то еще?
or something else?
По поводу JIT. JIT со
As for
временем,
JIT,
наверное, и появится.
over time,
И
JIT
Гвидо даже писал
will
об этом,
be,
что он, в
and even
принципе, был бы
Gvida
не
wrote
против,
about,
если
he
бы,
would not
JIT
mind
появился.
having JIT within.
Вопрос в том, в каком виде, да, и
It's
когда,
more of a
потому что,
question
скорее всего,
when
раньше,
and
чем
in which
3.14, а то и
shape,
позже,
because
я думаю, он не
I
появится,
think
да?
it's
Ну, это зависит, опять же, там, насколько будут усилия
314
там
the
вкладываться, да?
earliest, depending on their effort,
А
the
ускоряться
effort they
будет за
invest
счет
into it.
разных вещей. Например,
Acceleration
там
will be happening due to
постепенно
different
вот
things. For example,
микроинструкции
gradually,
меняются,
the
и
micro
они
instructions
будут
are
более
changing,
оптимально
and
сделаны,
they will
как-то
be
там
more
виртуальная машина
optimal
будет
somehow.
оптимизироваться.
VM will be optimized as well.
Спасибо большое.
Знаешь, у меня стойкое впечатление, что вы обсуждаете 8-ю
I
книгу о
have the
Гарри
strong feel
Поттере
you're
сейчас.
discussing like the 8th Harry
Как оно
Potter
там будет?
book.
На чем они будут летать? Старик, просто
How?
подойди к спикеру.
Why
Всё,
will they fly?
хватит.
Dude, just get to the speaker. Stop it.
Кому мы подарим
Stop
за
it.
лучший вопрос?
Who will get the prize for the best question, man? Woof.
Я вот думаю, парню, у которого больше всех вопросов
This
было.
dude who had many
Отлично.
questions.
Отлично.
All right.
Вопросы классные, спасибо.
Махни,
But
пожалуйста.
I love the questions too.
Василий,
Just wave
тебе
your hand,
тоже
okay?
с собой памятный
Vasily,
приз.
prize
Спасибо
to
большое,
remember.
спасибо большое за выступление,
Thank
за
you so
работу,
much for
за
the
подготовку
presentation.
и за
Thank
все
you
ответы.
for
Спасибо
the
всем.
work,
Boom.
for making this happen, and for
Отлично.
the answers to the
Друзья,
questions. Thank
нам
you. Boom.
предстоит прерваться на
Friends,
10 минут,
a
и потом
short
в 5
10-minute
будем
break as
говорить
usually,
про статические и
and in
лексические
10 minutes we'll be
анализаторы.
talking about static
Перерыв.
analysis.